Hey guys, this is Mr. Dahl here, just hanging out in the Mark. Going to make our next flipped video lesson, and in this video lesson we're going to be looking at equations specifically set up to be solved using a specific property, and that property, as you can see below there, the zero product property. So let's talk about the zero product property. Some of you may have heard it before, others may not have. The zero product property says if two or more factors have a product of zero, are equal to zero, then at least one, but possibly more, of those factors must be zero. Alright, let's look at some examples to help us understand and wrap our minds around what this is saying here. So if we have 12x equals 0, what we have is two factors, 12 and x, on the left-hand side of the equation equal to 0 on the right. Well, the zero product property tells us that one of those factors must be 0 for the product to equal 0. Since 12 is 12 and can't be 0, that means and tells us that x must be 0. Another example down below there, as you can see, where both of our factors are variables. If we have a times b is equal to 0, well, what zero product property tells us is either a has to be 0 or b has to be 0. It's impossible for neither of them to be. And since a could be 0 for this equation to be true, and b could be 0 for this equation to be true, what that means is we have two different ways this equation can be true. And just like with our absolute value equations, if there are two ways for an equation to be true, that means there's going to be two solutions. But we'll get to that in just a little bit. One important fact when we are using the zero product property is we never want to distribute and get rid of our factors. You can see in this equation here we have x minus 3 times 2x plus 5. We could simplify that expression on the left-hand side by distributing, but if we do that, we're going to lose our factors. And we want our expression that's equal to 0 to be written in its factored form, to be written as factors if we're going to use the zero product property. So for right now, do not simplify, do not distribute when we're trying to use the zero product property to solve equations. Alright? So let's take a look at that equation there. What we've got is an expression with two binomial factors, x minus 3 times 2x plus 5. So what does the zero product property tell us? Well, it says that one of those factors has to be 0. The question is, which one is 0? Well, we don't know. It could be x minus 3, it could be 2x plus 5. So since there are two different possibilities for this equation to be true, we're going to have two solutions. And if we're going to have two solutions, we have to write two equations. So our equations are x minus 3 equal to 0, or 2x plus 5 is equal to 0. Once I have written created these two separate equations, now I can solve them each individually to get my two solutions. We can see that our solutions are x equals 3 and x equals negative 5 halves. Now, once again, let's review this. If those are solutions, when we substitute them back into the equation, they should make the equation true. So let's check that. Alright, so if x is 3, and I substitute 3 back into my original equation, you can see I end up with 0 times 11, and we get that simplifies to 0, so 0 does equal 0. The equation's true, 3 is a solution. Let's do negative 5 halves. I know we don't like fractions, but I did the work for you there. So you can see what we end up with is negative 11 halves times 0, which simplifies to 0. And again, we get our true equation of 0 equals 0. So this verifies that 3 and negative 5 halves are both solutions to this equation. So we notice there are two solutions, right? Now, how do we know that there's going to be two solutions? Will there always be two solutions? I guess is maybe a better question. And the reason there are two solutions is because there were variables in both of our factors here. And the x minus 3 had a variable and the 2x plus 5 had a variable. Since there was a variable in both factors, there will be two values, one from each factor, which would make our equation true. So we're going to have two solutions. Let's look at an example down below here. In this equation, how many solutions would this equation have? Well, hopefully, thinking about what we just said above, you realize there's going to be 3 solutions, one from each factor, because you can see there's a variable in each factor. If we have a factor that does not have a variable, then that factor will not be contributing a solution to the equation, to the problem there. But every factor that has a variable, when we use the zero product property, will be giving us a solution there. So we've got a couple examples here. Let's walk through these quickly together. So on the left we have negative 3x plus 1 times the quantity 10x minus 7, and that is equal to 0. So we have two binomial factors. So using the zero product property, I can create two equations with each factor being equal to 0. Once I do that, these are just two-step equations, which we covered at the beginning of this chapter. So I'm going to cancel the constant and then cancel the coefficient, and then we get our solutions of 1/3 and 7/10. All right. In the second one over here, you can see we have a monomial x, only one term, times a binomial. Well, we treat this the same way. They're each factors. So we set x equal to 0 and 3x plus 12 equal to 0. Solve the 3x plus 12 equal to 0 because the other one is already, x is already alone, right? And we get our two solutions there. Now, if you have any questions at this point, please make sure you note them on your notes and be ready to ask about them when we come to class. So let's try some on your own now. We've walked through this together. We've kind of explained zero product property. So these equations are set up to be solved using the zero product property. So we want you to pause the video, try these equations, then come back and check your answers. Ready? Pause. All right, let's see how you did. Hopefully we got these solutions. Now guys, again, if you did not get these solutions when you solved our equations, please, please, please come to class and ask questions. Well, that brings us to the end. Hopefully this was a party for you as much as it was for me, and we'll chat more about it in class. See you then.